Very good evening, Harika. Okay, so let's just continue with the class. Okay, first of all, wishing you very good evening, everyone. It's going to be the third session on Amine. So let's continue. As you already know, in the previous class, we discussed about that is the Hofmann bromide reaction there. Okay, so let me just give you a quick brief about the reaction. So this is the reaction which we already covered, like the main part, mechanism part left, which we are going to cover now. So it's a Hofmann bromoamide. If you remember, there we discuss about that kind of rearrangement reaction. In the rearrangement reaction, we discuss about four type of reaction. That is a Hofmann bromide reaction, Schmidt reaction, and then very good evening, sir. So Schmidt reaction, and then Lausanne rearrangement, and then one is the Curtius there. So this part we already covered, if you remember. So like Hofmann bromide degradation, we are going to discuss about this point as well, like why the name of the reaction is the degradation, means something is going to degrade, right? So this is the first topic of the class. Again, let's quickly write the general reaction. So if you remember, in this case, we are having a kind of RCONH2, that is some amide is there. And which kind of reagent we are using? We are going to use some kind of bromine, and a 4 mole of NaOH is there. That I already told you, you have to maintain the 1:4. And then there is a formation of RNH2, means this carbon, okay? So this R has a one carbon less. Like if you are observing in this case, that carbon is going to remove, and then plus Na2CO3 plus that is a 2NaBr, and plus 2 molecule of water is there. So I already told you that you have to remember the stoichiometry there. So this is a kind of general reaction Hofmann bromide degradation. So now let's continue about the mechanism part, as we already discussed the main part. Now let's talk about the mechanism here. So let me just write the mechanism, like how the reaction proceed. So mechanism. In this case, that first step is the acid base reaction only. Okay, so acid base reaction. So what is the meaning of this word, that is acid base reaction? Listen, in organic chemistry, if there is a choice of acid base reaction, so the first step is always this. So acid base reaction is the step number one in this mechanism. Okay, you can directly remember the mechanism, or you can mention the step. It's totally your choice. Okay, so like acid base reaction is there. So let's see how to proceed. So first of all, like the substrate is the amide. So this is my amide, and we are using a base, right? We are using a base. What was the base there? That NaOH. So it means OH is being like a base. So what is the main what of the base? To abstract the hydrogen there, right? So in this case, if you're observing this hydrogen is acidic in nature, so this base is going to abstract this hydrogen. Let me just write be like this. This OH simply attack here. Okay, and this is how the bond open up, and we are getting that R CO, and this is a NH negative is there. Okay, it means one hydrogen is abstracted by the OH ion there. So acid base reaction, normally this is a base, this is a acidic proton. Okay, so now we are ready with this. That is the point number one. Now let's see the step number two. So what is the step number two? That is the formation of N bromamide. Okay, formation of N bromamide. Okay, so like what is the meaning of this word N-bromamide? Just think about it. Actually, what is it? It's be like that nitrogen is going to combine with bromine. You know that N-methyl, the nomenclature part we discuss. It means maybe the nitrogen is going to combine with the bromine part here. Okay, so let's see how. Now we are having this R, CO, and NH negative is there. Okay, so as you already know, let me just move again. This is bromine, right? Br2 there. So let's see how the attack is there. This is the Br, this is the Br, and then okay. So simply this attack here, and this bromine leave. So what we are getting now, that is a R, CO, and this N, H combined with the bromine. Okay, so this is this if you're observing that N bromamide. This is this N bromamide. Okay, so this is a step number two. Normally, first of all, we are very good evening, Lakshmi. So after so many days, you're busy with something. So this is the step number two. Now let's see the step number three. after this is generated, right? Let me just back n bromamide. After the generation of n bromamide, there is an intramolecular rearrangement is going to happen. Do you know the step number three is a common step in every kind of rearrangement reaction? So the step number three is what? It is a intramolecular. So as the name suggests, that in this case we are not going to add anything from outside, that inside the rearrangement is going to happen. So it's an intramolecular rearrangement. Okay. So let's see how that it's going to proceed. Like in this case, it's not difficult point. Just try to understand actually how it is going to happen. First of all, this is R, then CO, then N. Okay, let me just write the HB like this. And this is the bromine. Okay, still, as you know, we are using a 4 mole of a base. So still base is also present there. So this is a base OH. Okay, this is going to abstract the proton from here. Now, R, CO, nitrogen. Okay, there is a negative charge on a nitrogen, and this is the bromine. So let's just try to understand actually how the reaction is going on. First of all, see this negative charge move here. Okay, this complete R move here, and this bromine leave. Okay, I'm repeating one more time, listen again. So actually what is happening, it's a rearrangement. That simple. This negative charge move here. Okay, this complete R detach and connect here, and this bromine leave the molecule. Okay, so it means that what is happening, you can say this bromine is going to leave. Okay, and there is a R, wait, so I can write be like this. This is a CO double bond, and this and nitrogen will remain same, and R going to connect here. Okay, let me just highlight in a double bond as well. So look at this. This R now combine here. Okay, and if you're observing, this nitrogen is just simply sandwiched between this C1 and R is there. So this is a rearrangement. This is a kind of rearrangement is there, and as you know that still H is also present there. So there is a formation of what? NABR. You know that Na positive from this NABR. So Br negative means, try to understand. You already we already discussed about the final reaction. So NABR is there. Like observe this NABR. Okay, so Br negative means NABR formation. You can just simply consider, and this is the thing which we really want. If you remember in the previous class, at the end of the class, I told you about that is we are going to end up with the intermediate. Okay, so this is this intermediate. What is the name of intermediate? And this intermediate, every time we are going to deal when we are dealing with the rearrangement for the nitrogen family, so it's a isocyanate. It's a isocyanate. This is an intermediate is here. Okay, and the last step is very simple. Simple hydrolysis we are going to deal. Okay, so let's see the last step. Step number fourth, that hydrolysis. Okay, so let's see how to proceed. You can directly write the hydrolysis, or you can be like hydrolysis of isocyanate. It's totally your choice. Okay, hydrolysis. So let's see what is going to happen. First of all, this is a C. Okay, so this hydrolysis step is little bit be like, I can say it's a tricky there. Try to understand actually what is happening. So water, you know the meaning of the hydrolysis. We are going to use the water. So this is a water there. Oxygen as a lone pair. Okay, so this OH attack here, and this bond open up. Okay, this is the point. And then next, like carbon, this bond open O negative, and this is O, H and H. Okay, and double bond nitrogen and R is still there. Okay, so let's see actually what is happening. You can say this O simply attack here. Okay, and this hydrogen is directly and indirectly abstracted by the nitrogen. Okay, abstracted by the nitrogen, and this is how the bond break. Okay, again, just try to understand. We are not going to write the thing be like that way. Okay, just simply hydrolysis, and okay, simple transfer of proton I can write. So again I'm repeating, this hydrogen break the bond. Okay, and this nitrogen has a lone pair. Try to abstract the hydrogen from here. Okay, and this is how the bond open up. So this is a single step reaction. Okay, and let me just write that how to write this in a paper or exam, because it's going to be difficult, right? That how to represent. So you can say that is a proton transfer simply. Okay, proton transfer. So what is happening after that? That is this is now combined with the OH, and this is O negative, and now nitrogen is connected with one hydrogen, and this is a R there. So this is the proton transfer. If you're observing something, this hydrogen basically simply moving from there to there and connected with the nitrogen. Okay, this is the point number one. Now let's see the point number two again. Uh, okay. So yes, I missed this oxygen. So this oxygen simply now here, so it's a double bond oxygen, right? Because otherwise the carbon valence is not fulfilled. Okay, so this is a double bond carbon. Now this is the first point. Now let's see the next step again. Again, we are going to write that as a proton transfer. So this lone pair abstract this hydrogen from here. Okay, so let's see actually what is happening. Next step, again, you have to write proton transfer every time. Okay, no need to represent the arrow be like this because otherwise the every time the problem with the arrow. So just write proton transfer, it's more than enough. Then how it's look like. That is this double bond will remain intact. This is O negative. Okay, now nitrogen is connected with two hydrogen and R. So basically if you are observing something that these two hydrogen, this hydrogen, so these two hydrogen basically transfer to the nitrogen there, right? Simple. That is a transfer of proton take place from water molecule hydrogen to the NH there. And now nitrogen is positively charged. So let's see actually what will be the next step that this simply attack here and this molecule leave. Okay. So last step, what is the final step? Let me just try to write here. Okay. So this first of all CO2 molecule release. Okay. First of all CO2 molecule release, how it is going to release. If you're observing, this is nothing. It's a CO2 molecule. Okay. The point number one. And the point number two, that plus this R NH2 release. As we already discussed about that in this rearrangement, we are going to end up this wait, Lakshmi, we are going to end up with the primary amine. So no need to remember like every point. Let me just highlight that how to remember this. Simple, you have to remember that isocyanate form. That intermediate is really important here. Okay, so this is like a stepwise reaction. And now let me tell you like how you're going to deal with this in a paper. Okay, because obviously so many step and it's very difficult for us to remember directly, right? So let me explain in a very simple way. That is a single step how it's really look like. Okay, so let's suppose I'm writing a mechanism in a paper. Okay, how to deal because it's important and of course it's a part of a board exam as well. So let me just write the mechanism in a single step. So first of all, this is my amide. Okay, this is my amide and this is a OH molecule. So this is a step number one. What is happening? Like this step, everyone you know. What is happening? There is a formation of RCO and N negatives there. That's it. Then this is the bromine and bromine. So this is bromine basically. This is bromine as well. So this attack here and this is how the bond open up. And this is RCO and N H and R is there. Sorry, BR. Okay, or better to write, wait, let me just write one more step, right? Okay, that's it. Next step is again OH is there. So OH is going to abstract this hydrogen. Then again acid-base reaction. So this is negatively charged and this is a Br there. Okay, this is the next step. Now, next this R simply move here. Okay, this here and this. So this step at least you have to represent. If you're not going to use these arrow, it's okay. Okay, just simply write OH and it's totally understood that it's going to abstract the hydrogen. Okay, but this step is really important. Then after once that we are getting a intermediate. Okay, so what is the intermediate? That CO. Okay, and then double bond nitrogen and then R. After this simply write hydrolysis step and then simply form CO2 and plus RNH2. This is enough for the exam. Okay, so the hydrolysis step, as I already told you, it's a optional. Okay, this is the like stepwise mechanism how to really deal with it. Okay, but if you are able to write this much information in a paper, it's more than enough for the board exam. Okay, Lakshmi. So this is the thing. Let me just move again. That this slide you have to remember only. This is how you have to write the mechanism in a paper, and it's enough. Okay, everyone. And like this is a stepwise. Okay, so again, you have to note at the step be like acid base formation of n broma. You know that how to gain the mark in a board exam. This is just the writing matter only. So this is how you can proceed simply. So option like this is a step number four, and this is a complete overview of the mechanism. Okay, that's it. This is a bromide degradation there. Okay, now you be like, ma'am, but still we are not getting Na2CO3. So the CO combined with Na, so there's a formation of Na2CO3 form. Okay, and then one more NaBr. So balancing is a different part. Okay, every time this is a common intermediate. Let me just write all the reaction now one by, and you'll be like, this is a common step. Every time isocyanide and at the end CO2 molecule release. Okay, let's proceed with the second rearrangement so that we are going to observe the trend between them. Okay, first of all, anyone, any kind of problem with this mechanism? Yes, please. Any issue with this mechanism? Is this clear for everyone? Okay. Again, I'm repeating, it's important. If you are not getting, let me know. I will explain one more time. Okay, so I hope done. So this is all for the mechanism. Okay, now let's solve a question. Okay, okay, just answer the question. Okay, which of the following? Actually, I just want to check the basics of the migration. Okay, that's why I'm asking this question. So, which of the following compound, which of the following compound can't give Hoffman bromide degradation? Okay, you have to just let me know that in the given like substrate, which substrate is not going to participate for this reaction. In short, we are going to just check in which case there is a there is a formation of primary amine. That is the correct answer. Okay, so let's see how. Okay, so option number one. This is a option number A. This is normally carbon CH3 CH3 and then CONH2. Okay, now like B is there. And please be noted, question asked about can't. It's not like which one. Be noted. This is NO2, C, and option number D. So which of the following is not, I can't give Hoffman bromide direction. Yes, please answer the question. Okay, B. Hint, primary amine is the final product. Okay, check it for which, like for A, B, C, or D, in which option we are not getting primary amine. Okay, okay, Lakshmi, I'm waiting only. Take your time, everyone, and then answer the question, please. And it's a PYQ. Let me just check the year. It's a J main question. Okay, Neharika. Okay, so let's see. Let's try to understand the question. Okay, so let's just start with the option number A. In the option number A, if let's suppose I have to start normally, okay, so look at this. This is going to migrate simply that according to the mechanism point of view. Okay, so this be like that in this case the C part is going to remove. Okay, if you want to understand like a shortcut how to deal with directly, that is remove the CO and then connect the nitrogen with the carbon. So if I'm removing the CO, so what is happening that I can say my NH2 connected like this. Let me just erase this. Okay, so this is my final product. This is my final product in option number A. Can you just tell me the degree of this amine? What is the degree of the carbon or the product? Sorry, that is the product, you can say. Product A degree. No, no, like migration is not connected. Like migration is the issue when we are having a different, for example, with one is donating, one is withdrawing. So in this case, this is not the issue, okay? Primary, I mean. Okay, so some would be like, ma'am, how it is primary? Isn't it that the tertiary there? Like nitrogen connected with this carbon and no, 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 no way. You know what is primary, I mean, what is secondary, and what is tertiary, I mean. So let me quickly give you a brief that when nitrogen connected with one carbon, so it's primary. When nitrogen connected with two carbon, it's secondary. And when nitrogen connected with three carbon, so it's a tertiary amine. You know? So let's just back here. It's still a primary amine. So it can be the product. Yes, it can be the product. Option is definitely correct. Okay, but how about the option number like B there? Again, like apply the sort trick, remove the CO in between. Okay, let me just remove this. Okay, and then what is happening? Isn't it the aniline kind, nitroaniline? And yes, this can be the product, primary amine again. So it is also the correct answer. It's a primary amine. Now, how about the C? That if you're to go with the C, let me just erase the CO now and now let's connect them. So what is it? If you're observing one side nitrogen connected with phenyl and one side nitrogen connected with the CH2 group, so it's a secondary amine. Okay, it's a secondary amine. That's not a primary there. So hence option is the like not the product of this reaction, or option C is the correct answer. You know, we are going to discuss about can't, so that's why option C is the correct here. Similarly, like in this case again, if I'm removing this CO in between, and what is this? This is normally that is aniline, right? So very good. That Niharika and Lakshmi, option C is the correct here. Okay, so it's easy question. Just try to understand the basic point, and it's going to be the easy again. Okay, that's it. This is all for this reaction. Now let's proceed with the second kind of rearrangement. That is going to be the Schmidt rearrangement. So let's see. This is all for this case. Let me just check any important part. So, yes, that's it. This is all for the isocyanide. Now, anyone, have you heard about that isocyanide somewhere? Okay, let me just ask you a question. Can you just tell me the gas which is responsible for the that is a Bhopal gas tragedy, tragedy, or you can say. Yes, please. Maybe you already heard about the isocyanide somewhere. No, no, Bhopal gas incident. What was the name of that gas? Okay, let me give you the options just for like methylamine and B ammonia, or C is phosgene gas. Phosgene, right. And option D, this is methyl isocyanate. Yes, please. If you know. You're hearing first time. You don't know about the. Okay. So you know that which one right now. Chernobyl explosion. You know that? Arul? Yes, you're right, Lakshmi. Yes, methyl isocyanate is the correct answer. Okay, so if you don't know about this, Arul, so it means your history was very weak, right? It's a basic question from the history. Okay. Yes, of course. It's a very important part. I guess if you remember the Second World War, so definitely you know about this. Okay, Rul. Anyway, if you not heard about this, that is in Bhopal, from a chamber, this gas leaked, and this is highly poisonous. Okay, and just because of this explosion is there, and so many people died. I guess approximate around 1500 something. Right now, I don't know the real number, but it's be like Chernobyl explosion, a very famous kind of explosion. Okay, so methyl isocyanate is the correct answer. Option D is there. That's it. This is little bit about the isocyanate kind of history. Okay. So anyway, let's move further. This is all for the reaction. Now let's see the second one. Okay, that is schemate. Let me just write the normal reaction first. Okay, so rearrangement number two. Okay, I already told you the short trick. That is a sorry, that is a school, high school living certificate, right? This is how you can remember. Yeah, that was in Ukraine. If you watch the web series, Chernobyl explosion, so maybe you already know about this. Okay, that Hiroshima, Nagasaki, and this Bhopal gas tragedy, and then one more Chernobyl explosion. So yeah, very famous explosions. So now let's continue. Let's see the second one. That is Schmidt rearrangement. Same like every naming reaction. What is substrate? What is the reagent? What is the product? Okay. So let's start from where we have to start. In this case, the carboxylic acid. We have to start with the carboxylic acid first of all. And about the reagent? In this case, we are using a very special reagent. This is the N3H. Can anyone tell me the name for this? If you know, N2 H2SO4. Yes. What is the name for this acid? This is one of the famous acid in inorganic chemistry. Or you can say in 15th group, P block element. Yes, please. What is this? Okay. So it's a hydrazoic acid. Okay. It's a hydrazoic acid. It's not NH3, it's N3H. Okay. It's a really important acid of the inorganic. Anyway, this is all for the kind of introduction. And again, that every time the final product is going to be the primary amine. Okay. For every kind of rearrangement, primary amine only. So now let's write the general reaction first of all, then again the mechanism part. So how about the general reaction? If we are discussing about a general reaction, so in this case, again, this is a R, CO, OH, and then N3H. And in this case, we are using H2SO4. Most of the time, we are using bases, but in this case, H2SO4 we are using. And then again, the same side product. First of all, we are getting primary amine. Then there is a formation of CO2. CO2 is a common thing. And in this case, there is a N2 is the plus point because since we are using a 3 time N. So one N is going to fit with the carbon and two N is released as a N2 gas. Okay, so this is the extra point here. And then example be like, okay, it's easy, you can use any example. So example, let's suppose this is my CH3 acetic acid. Okay, and then I'm using this same H2SO4. Okay, let me just write full H2SO4. So this is H2SO4, and then again this is going to be the CH3 NH2 plus CO2 and plus N2 gas. This is a general reaction. Now the real part start means mechanism. So let's go with the mechanism, how to deal with the mechanism again. So Arul, the only good way is what? That write the naming reaction continuously 4 to 5 times. Okay, Arul? Then we'll get a hang and then it's easy for you. Okay, and otherwise just make a kind of chart and paste in your room and keep revising them. Okay, this is the only way because it's a cramming, and cramming is very difficult, especially for the math student. So actually this is the only way, Arul, no shortcut. So let's back. Let's talk about the mechanism. So again, same, let me just tell you the proper mechanism be like step wise and then you can go like the previous one, a simple reaction. So again, that how about the step number one if we are discussing about this. So the step number one is the formation of that is the acylium ion. Okay. So can anyone tell me what do you mean by this word acylium ion? Maybe you already observed this somewhere in the 11th class. Okay, recall till then. Let me just write the reaction then. So in this case, formation of acylium ion. So in this case, this is R, this is a CO, and this is my OH, right? And think about it. In this case, if you're observing again, the reagent is the H2SO4. Yeah, of course, this is also the reagent. But to observe this, the step number one is the formation of acylium ion. If you don't know, this is this R, CO, and triple bond oxygen. This is acylium ion. This kind of electrophile we are end up within Friedel-Crafts acylation, if you remember. Okay, so like this. Anyway, so first of all, this is H positive. You know every time that what is which kind of reaction is going to happen. Whenever OH present, H positive present, definitely water molecule is going to remove. So this lone pair attack on H positive and there is a formation of RCO, and then this is how the water molecule ready. And this is going to simply release there. Oxygen as a lone pair, oxygen simply participate and this is how the water molecule remove. And water molecule, after the removal of the water molecule, we are getting this. Okay, so like if you want to restore that this is a positively charged, so there is a kind of resonance as well. So in this case, the carbon have the positive charge and this is the this acylium ion. So we are ready with our attacking, like you can say, substrate. Okay, this is the step number one, formation of acylium ion. Okay, now let's see the step number two, that is the formation of, so let's see the next step, that is the formation of protonated azide. Okay, so let's see, this is a step number two. Now let's see actually what is going to happen. This is R and this is CO and carbon has a positive charge, right? And then in this case, we're using N3 and hydrogen. Okay, like this. So in this case, if you know, it is a kind of covalent bond. This one has a partial negative charge, there's a partial positive charge. Okay, so if you want to write the structure, this is structure look like there's a double bond nitrogen, double bond nitrogen. There's a negative charge, this is a positively charged, and this is how the hydrogen connected. So this is how this NH3H look like. Okay, so just think about it. In this case, this nitrogen, okay, this nitrogen is negatively charged, so this is going to simply attack on this carbon. Okay, actually this is how the reaction going on, but in order to understand be like how, just simply consider there's a negative charge on a nitrogen and it is going to attack here. So what will be the next step, that is R. So the carbon, this will remain same, and this is how the nitrogen N3 simply connect here. Okay, this is a simple sorted, that is a protonated azide. Okay, so of course hydrogen is also connected here, so this is a protonated azide. So you know what is azide, that when this nitrogen combine with this carbon and one this hydrogen, so this kind of thing is known as a azide. Okay, so azide is ready now. Now after this next step, okay, let me just write properly. So double bond, so it's a double bond nitrogen and then triple bond nitrogen positively charged and hydrogen connected here. So we are ready with our protonated that azide. So this is the final structure we are getting. Okay. Now, after once it's generated, let's see the next step. That is the step number three again. That is intramolecular rearrangement. I'm erasing this, okay, so that we can write the step number three here only. So what is the step number three? Step number three again, that is intramolecular rearrangement. See that how beautifully the rearrangement is going to happen. So it's an intramolecular rearrangement again. Okay, so let's see how that this is R. Okay, we know one thing that our final product have to be the isocyanide. Okay, so again, if you don't know how the arrow is moving again, so in paper, just simply write intramolecular rearrangement and form the isocyanide. Better for you. And then this is a double bond, triple bond, sorry. and this is a positively charged. So let's see how the arrow is going to move. So in this case, nitrogen has a lone pair. Okay, so nitrogen lone pair attack here. Again, this R attack here. Okay, simple. And then this N2. It's this N2 leave. It's living. Okay, so let's see actually how it's look like again. I'm repeating this step one more time. Okay, same like if you're observing every time double bond is going to be there. So this lone pair attack here, R simply attack here, and this is leaving. Okay, so this the point, the first point here, that N2 simply leave. Okay, so what we are end up there now, that is a CO and double bond nitrogen still. What is the point here, that hydrogen will remain intact with this nitrogen here, like this. Okay, so let me just write hydrogen and R is there. So since nitrogen having four bond here, just because of that the positive charge here. Okay, so this is our intermediate isocyanide is ready. Okay, so in this case iso, this is our intermediate again, isocyanide. So it's an intramolecular rearrangement like the previous one. Next step, hydrolysis. Okay, if again you don't know how to write the hydrolysis step, again just simply write hydrolysis and then simply form that is a CO2 gas release and RNH2 there. Okay, it's totally your choice. So let's see how to proceed then. Okay, step number 4, that is hydrolysis. Okay, all four kind of mechanism ditto, same. Okay, same step is going to happen. So let's see the last step, that is hydrolysis. So how about the hydrolysis? This is my CO. Okay, again, H is already connected here, and this is R, and a double bond. This is a positively charged. So again, water molecule is going to attack. So let's see that water again. This is the water. Oxygen, sorry, that oxygen as a lone pair. It's attack here. Okay, since this oxygen is going to combine here and carbon is already having a four bond, so this bond basically open up. Okay, so let's see, that is a carbon, water, and double bond, and nitrogen, hydrogen, and this is R again. Let's see the next step, that again the proton transfer simply. Okay, proton transfer. So let's see how about the proton transfer. Okay, it's a proton transfer. Let me just write fairly. So again, there is a proton transfer, or you can say exchange simply there. So same step, that oxygen, just because of the positive charge, this hydrogen break the bond. Okay, nitrogen has a lone pair, abstract this hydrogen. Okay, simple like the previous one. So what is happening then? There is a CO. Okay, and this is OH, and nitrogen, there is a hydrogen, and then R. So again, that like the previous one, the same step, this OH attack here. Okay, this is going to leave. So what we are getting, that is CO2 molecule remove, and there's a formation of NH2 and R. RNH2 is ready, or primary amine is ready. Okay, like the previous one, no need to represent all the steps again. Okay, simply write hydrolysis and just go with the primary amine CO2, and that's it. Okay, so this is a full mechanism. Again, you can go with the shortcut like the previous one. Okay, so this is the second reaction, Schmidt reaction there. Okay, like the previous one, if you want to brief again, let me just write in a single line, right? So again, that what is the step quickly? This is R, OH, this is a positively charged attack here, and this is R, CO, O, H, positively charged, it's remove, and this is R, CO, and positive. Next step, that nitrogen, hydrogen, negatively charged attack here. So then there's a formation of R, C double bond, nitrogen, hydrogen, nitrogen triple bond nitrogen, and this is a positively charged. And the next step is the intramolecular rearrangement. This is simply attack here. This is how the bond open up. The nitrogen molecule is going to remove. N2 is there, and then this is a CO, and this is nitrogen connected with R, one more hydrogen. This is a positively charged. Okay, the last step is the hydrolysis. After the hydrolysis, we are getting basically the primary amine plus CO2 molecule. This is a single step reaction or single step mechanism, that how to write. Okay, so that we can skip so many arrows. Okay, that's it. This is a simple single slide mechanism for this. Okay, this is all for the schemic reaction. Okay, now Okay, any again, any problem? First, let me know. I guess it's very fast, right? So yes, please, any problems for this reaction, if you are having, please let me know. Okay, now that a very important application for this chemid reaction is there. Okay, so let me just write how a kind of knot you can say. So this is a very important knot. What is the knot? Knot said that is this reaction. Okay, as we discussed, the skimmed reaction is only for carboxylic acid, right? But it's a kind of knot that is this reaction. Skimmed reaction can be take place. Okay, can also you can write. Okay, also take place. Also take place with aldehyde and ketone as well. Okay, ketone as well. One of the famous application for this part is the caprolactam. Okay, although it's a part of the polymer, right now polymer is deleted from the syllabus. Otherwise, it's very famous caprolactam formation is there. Okay. Anyway, let me just write the name. Okay, we are not going to deal with caprolactam now. So simple that let me just start with the ketone. This is RCOR, and in this case, if I'm using N3H and then I am using a kind of H2SO4. So what is happening? There is a formation of RCO, and listen, this nitrogen is going to fit here. Okay, simple. In between CO and R. So what is the next? The point is there that this NH is there and this is my R. Okay, and plus N2 gas release. N2 is the part of this N3H is there. Okay, so again I'm erasing this, and let me just highlight actually what is happening. This N is just simply fit between this and this. If you remember, it's be like bare vinegar oxidation if you remember, right? The oxygen fitting there. So same here. Okay, and the one I'm talking here, the caprolactam. So how to proceed? That you will be having a kind of cyclohexane. Okay, so this is a cyclohexanone. So in this case again, we are using NH3 and then H2SO4 simply. And then again, simply that nitrogen is going to fit here. And let's suppose if we are not having a kind of which one? That is symmetric. Let's suppose that this is here. So you know the basic rule that more substituted one is going to add. Okay, so like N is attacking on that side. If symmetric, not an issue. Otherwise, every time the nitrogen is fit on which side, where the more substitution is there. Okay, it means that let's suppose I'm starting with this reagent and same reaction we are going to proceed. So the final product be like oxygen, then double bond. Okay, like this. So this is a final product. See the difference that in this case, this N is, oh, I'm sorry, not nitrogen, oxygen, nitrogen. So this is my NH simply. So this is the important point. Okay, this is all for a kind of not. It's important for you. Okay, that's it. Okay, this is for the second reaction. Now let's see the third one, courteous. Now repeated. Okay, let's see the courteous. Courteous is very much easy. Okay, so let me just write the next reaction. That is a courteous reaction or the rearrangement. We are discussing about the rearrangement. So it's a courteous rearrangement, same like product or like substrate. So in this case we are going to start with the substrate that is acyl halide. Okay, acyl halide. Every time primary amine is the final product. Okay, so the final product is the primary amine only. How about the reagent? So in this case reagent is what? NaNH3. Noting something that in the previous one we are using N3H and then H2SO4, and what was the use of this H2SO4? To generate the psyllium ion. But in this case we are using sodium hydrazide. Okay, so that's this is a simple like, or you can say the different point from the previous reaction. So what is it? It is sodium azide. It's a sodium azide. Okay, so ready, I guess. Now let's discuss about the general reaction, same mechanism. Now it's ditto, same repeated. Okay, easy. So let's see how. I know that it's not easy, but still COCl and then NaN3, and obviously obvious hydrolysis and then heat this. We're getting some R NH2 plus NaCl and then CO2, okay, and then N2 gas. So in this case, this, everything is there. Okay, so all are the product here. Yes, of course. Okay, rule. See, this is a common point in every. Let me just write this mechanism as well, and you'll be like, oh, it's easy actually. Okay, because every mechanism is almost similar. Problem when will you are having a problem in future, if let's suppose the reaction asking a question like Curtius, like which acid, okay? So that's why if you are requiring a kind of, rhymes. Anyway, so let's back. So this is all for the reaction. You can write any general reaction. Or let me just write again. It is a CH3, CO, Cl, okay, NaN3, and then water, and then heat. So it's a CH3, again the primary amine. So actually we are going to deal with the MCQ type question paper, right? So our main motto is what? Just check it for primary amine. But yeah, for the board exam, we are preparing for the mechanisms. That's it. Okay, so let's discuss about the kind of mechanism here. It's a very simple mechanism. Right now, I'm not going to explain to you the same all three steps. Simple single line mechanism. Let's try to write that. So how about the mechanism? You are having some R, CO, and Cl, right? So this time we are having perfect ionic bond. How the ionic bond is there? You know that sodium is just acting like a counter ion. So this is a nitrogen, and then nitrogen like this. This is a positively charged, and this nitrogen has a two negative charge, and sodium has a positive charge. So you know that sodium is just simply neutralizing the charge here. So let's see actually what is the step number one. This simply attack here. This bond open up. Okay, now everyone, maybe you know the basic criteria for the mechanism, that what is really happening there. First of all, this is a O negative generate, this is a Cl negative, and then this nitrogen okay connected like the previous one, and a triple bond nitrogen, still that nitrogen has a negative charge. Okay, so see this, that this oxygen simply moving here and this Cl molecule leave, Cl leave the molecule. Okay, so most of the time that we used to represent be like oxygen leave and again and then chlorine leave. So it's a single step if you want to so. Okay, otherwise you can follow two step. Okay, that is this is how the second step look like. And then I'm giving you just 10 second or 20 second. Try to observe what will be your next step. Okay, so in this case now after this, okay, let me just write the next point here. This is R and a double bond CO. Okay, and this nitrogen negatively charged and nitrogen and triple bond like this. This is the thing we are getting right now. So think about it, how to end up with the cyanide. Okay, I guess I already explained 2 to 3 times that how to end up with the isocyanide. Just try to observe the mechanism. Okay, not an issue, Arul. Yes, please. Take your time, 20 seconds, try to observe like how to move the arrows, how to rearrange the thing here. I guess you're done, right? So maybe I'm sure like how you're observing that this nitrogen has a negative charge. Every time we are doing. So let me just again moving toward the previous mechanism. See the you can say the common point, this step. Okay, see this that nitrogen has a lone pair attack and this is how living. And let me just move to the step number one where not the slide. Yes, again, nitrogen negative charge attack, and the something is living. Here, bromine living in the second, nitrogen living, and the Curtius one. Isn't it going to be the same thing? So let me just back again how to proceed. It's be like repeated. Nitrogen attack here, R moving here, nitrogen leaving the molecule. Okay, it's common thing. And then next is what? That is R, oh sorry, cyanide. So then isocyanide again, this is a CO, oxygen, and see double bond nitrogen and R is connected there, and what is automatically removed, that is N2 gas there, simple. Okay, it's a same ditto part here. And again how the hydrolysis step, if you're observing that again water come, okay, water simply attack here, okay, this bond open up, and then what is happening, that just because of this that we are getting this is O is there, Okay, hydrogen is there, and a CO, nitrogen, and then this is R. Okay, okay, let's see. This step is not because already single bond, for one. Now, if you're observing something that this nitrogen has a negative charge, so this nitrogen going to abstract the hydrogen there. It means proton transfer one more time. So after the proton transfer, what is happening? That is a proton transfer. So let's see. Okay, I will change the, I guess this is not visible, right? Let me just change the position. Okay, see this proton transfer. So what is happening after the proton transfer? Let me just write on the next slide. Okay, so that this is a CO, which nitrogen negative charge and R. So definitely nitrogen is going to abstract both the hydrogen from this, right? So let me just write after that protonation what is happening with the proton transfer. Okay, so it's a common thing. CO. Okay, this is O negative, and then nitrogen same positive charge, now same ditto, like if you're observing, oh move here, this leave again CO2 molecule, right? So what is happening, that again CO2 molecule removing or leaving from here, and we're getting RNH2. That's it. Okay, so same mechanism but like different kind of product we are just starting. Okay, so that's it. This is all for the Curtius reaction. Okay, let's just pack here if you're noting. So quickly, let me just quickly give you a brief. We are starting with the first one, Hoffman bromide. There we are using that kind of amine plus bromine plus NaOH. So first of all, abstraction of proton. Then there is a formation of that kind of negative charge on N, and then bromine combine, and then rearrangement, and then hydrolysis. The second reaction that is just commit there we are using a kind of acid, carboxylic acid, plus that hydrozoic acid. And in this case, we are using that RCOCl, or you can say acyl chloride or acyl halide, any halide, and NaN3, that is a sodium azide. And the same mechanism followed. Okay, so all three reactions is actually same, look like the same type of reaction. Now let's see the last reaction. Okay, or if you want to note it a kind of shortcut, so what shortcut is not like hydrolysis step. Okay, let me just explain the shortcut for the hydrolysis step. So it's a R, nitrogen, CO. So how to add the water? Okay, if let's suppose I'm having a water, so how to add the water? Simple, the CO2 remove here, and whatever be the case, this is combined with this, so it's a NH2. So this is how you can directly apply the shortcut for the hydrolysis step. Again, if you don't know the position of arrow, how the arrow is moving, please you can omit that in a papers. Okay, otherwise, negative angle, there's a less mark. You are getting that. So that's it. Let's see the next one. Last one, loosen rearrangement. So the loosen rearrangement. And I'm using so much time for the explanation of these kind of things. So obviously for all four rearrangement is really important. Okay. Not the complete amine chapter, but all three. So again, in this case, the important is what? Substrate. So it's a O. Acyl. It's a actually the name is already weird, but don't worry, name, you know, name doesn't matter here. So it's a ortho aryl derivative. Again, if you don't know about the name of a substrate, just write the structure. It's enough for you. Okay, don't be like, oh, oh, something is there. So please avoid these kind of small point in the papers. So it's a ortho acyl derivation. I'm sorry, what I'm writing. Derivative. So it's a derivative of hydro hydroxamic acid. So what very weird name, right? So let's see actually how it's look like. Let me just write the structure actually how it's look like. So first of all, observe this. Something is connected by like oxamic acid. So like CO, ic acid is only when we're having a COH group. So let me just try to explain this. First of all, this is a kind of thing, something like this, something like this. But now there is a very much important point there, that something is also be like O acyl. So O acyl, what is this? So you can say, in this case, what is happening? This is NH and this is OH. So something, look at this, the thing, hydroxy group, OH group. Okay, mic acid, it's be like it's a part of the carboxylic acid. And what is the meaning of OSIL derivative here? That the carbon connected with oxygen and that carbon connected with nitrogen, this is connected with one more oxygen. Okay, so like oxygen is the key point. This is how you can remember the thing. Okay, so again, if you're observing, this is how the structure look like. So you can say that what is happening in carboxylic acid, you have to just simply fit the nitrogen. Okay, so again observe this, that simply the nitrogen just simply substituted between the OH and a CO there. So same, that's why the name is what acyl derivative. It's be like, what is acyl derivative? That when in carboxylic acid we are just switching the OH with another group, right? So that's it. This is how we can remember that in carboxylic acid, just add nitrogen between CO and OH is there. So it's become that O acyl derivative of hydroxamic acid there. Again, if you don't know the name for the substrate, it's okay, but don't write the wrong name. Okay, this is important. Anyway, so let's see. The reagent is there. Okay, so there is a no step. I'm writing the reagent here. So what is the reagent? Reagent is OH negative and heat this. Something be like base we are using. Okay, so we're using simple sorted a base there. Okay, so product is same like primary amine. Okay, let me just write the product here, primary amine. So thank God that only one kind of product. Okay, otherwise so many name is there. So that's it. Now let me just write the general reaction first too, for like how to deal with this. Only the general reaction. Okay, so this is a kind of general reaction. Okay, so in this case we are going to deal with two kind of thing. Okay, but you be like, ma'am, you we discuss about only one thing and you are explaining the two thing. Okay, so I will tell you how. So in this case, maybe the point is missed here. Some of you will like, ma'am, but OSL is still not very clear. Something is connected with oxygen. So listen my point that in this case, there's a two kind of substrate we can use. The substrate number one are CO. Oh, I'm sorry. That NH combined with this OH. Okay. Since the substrate is the OSIL derivative, so which kind of derivative we can use, that we can switch this hydrogen. We can switch this hydrogen with one more COR. So if you're observing something, it's be like that in carboxylic acid or in between anhydride, we are just adding a NH. Nitrogen is there. Okay, so let me just write how that this is a kind of anhydride. This is a kind of anhydride. So NH is adding here, or like the previous one, that acid and NH is adding here. So two kind of substrate we can use. Okay, because most of the time in a previous year the question asked from this type. Okay, that R, CO and NH and no. So did the problem is not there, ma'am. We just discuss about Lows and be like OH is there. So OSL derivative, like OSL means hydrogen can be there, or like any group can be there, any R group can be there. Okay, so this is how the actually the base of this reaction. This is only important thing. Okay, mechanism is again single simple. Mechanism is not very difficult for you. Okay, so let me just write the general reaction. So what we're discussing, right? Okay, so how about the general reaction? We are going to discuss about the question as well from this part. So let me just write the general reaction, that you are having R, CO, and then NH and O and CO. This is some R2. So just try to understand, we can use R anything. Okay, they can be same, they can be different. It is not the issue here. So now let's see that in this case we're using a base, right? A kind of base. So if I'm using a base, like we discussed, base or heating, so we're getting a amine. Two things we're getting. First of all, if you're observing, this portion is go with the amine. Okay, so R1 NH2. And what will be the left part? This part, okay? This part is go with the acid. So like this is a extra point here. RCO. Okay, so this is extra point here. That is a RCOH, a kind of acid. And one more thing, like CO2 is going to release again. Okay, it means, um, I know it's difficult. Let me just explain one more time. This is the thing. So one portion go with this. It is going to be RCOH. Okay, second portion, this portion, it's, you have to treat it be like this is a kind of amine system that try to compare this with the previous reaction, if you remember that, which one, bromamide reaction, and then simply that this is R1 and NH2, and then CO2 gas release. That's it, two kind of thing. Now let's understand the mechanism. Mechanism is simple, just only the reaction is important here. Okay, so let's discuss about the mechanism. And okay, it's going to be the R2, right? So how about the mechanism? Okay, I guess my video is not there. I'm sorry. I forget about this. This is the position. Okay. So let's discussing about the mechanism now. So this is R, this is CO, this is NH, this is a O, this is a CO, and this is some R1. And in this case, we are using some base. So what is the use of the base? Base is going to abstract this hydrogen there. So next step, okay, this hydrogen. Okay, this hydrogen. So next is R1 CO. Okay, there is a N negative, and this is O, this is a CO, and this is R1. Okay, now next. Okay, it's actually one of the easy mechanism out of all the all four mechanism. So see this again, the same R attack here. This R1 is moving, and this group is living because it's a very good living group. Ester is a very good living group. So in this case, this leave, that R1 COO negative leave, it's living group. Okay, it's, I'm sorry, it's the R2, right? R2. So it's a R2 there. Okay, and again, what we are getting then, same ditto, same thing, CO double bond nitrogen, and this is a R1. Same isocyanide, okay? So same, this is a isocyanide. Okay, next step, hydrolysis. Add the water one more time. Okay, so we are having a space here, hydrolysis. So after the hydrolysis, what is going to happen? Same, water, adding CO, nitrogen, negatively charged R1. Now after this step, same mechanism, proton transfer. So this is my CO, water, positively charged, nitrogen negatively charged R. There is a proton transfer. So what is getting after the proton transfer there? That these two hydrogen again transfer to the nitrogen, right? Like as we are discussing again and again. And then this is a CO, O negative, and same last step ditto again, positive, this overtake here, this leave. So at the end again there is a CO2 molecule. So CO2 is the common thing. Okay, and this is RNH2, and since we are using R1, 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 so this is how R1 is there. Let's solve a kind of question, okay? Just try to understand this. Okay, again, mechanism is simple. Which attack on this negative charge, this is isocyanide, and then rearrangement hydrolysis, this is the last step here. Okay, so this is all for the mechanism. Simply mechanism is not difficult for this reaction. Okay, just observe. Okay, now let's all a question, like which kind of question ask from this. Okay, so this is a question. This is a carbon combined with CH3, then dash, this is Et. Okay, and then at wedge position hydrogen is there, and this is my CO double bond NHO, and then CO, and then CH3. Okay, let's suppose this reaction is given to you, R and water is there. Okay, so this is a kind of reaction for you. So you have to tell me the final product, or just take your time. Okay, try to draw the final product. Okay, and then I will reveal the answer. Just start now. What will be the final answer? Same, follow the process. Okay, directly apply the shortcut. Take your time, and 30 seconds for you. Try to write the answer, and then you can cross check with me. And one more thing, stoichiometry how to be maintained. Okay, that's why I'm taking this kind of question for you. Okay, when we are dealing with any kind of rearrangement, stoichiometry how to be maintained. Oh, sorry, I'm sorry. Stereochemistry. Okay, stoichiometry I use. Stereochemistry. Okay, that S become S, R remain R. Okay, it's not going to be changed. Okay, I hope you are done. So let me just write the product and you can cross check whether you're right or wrong. So this nitrogen, as I already told you, this is the part of this side, right? So this carbon, CO, like you two treated like this, the previous one, CO remove this, become CO2, okay? So the carbon, this is the CH3, hydrogen, this is my hydrogen already there, and the wedge position ET group is already connected, and NH2 group. So this is the product. Plus CO2 plus that this portion become acid, that is the CH3CO and OH is there. Okay, that's it. This is a simple this is how we are going to solve the question from this given reaction. Okay, this is all for the rearrangement, and I know that in today's class so many mechanism there, so many type of reaction there, they look similar but they're different. Okay, so the only way to remember the thing, write them, revise them, and that's it. Okay, although we are left with so many naming reaction, but let's deal in the next class. I guess it's enough for today, right? So yes, now your turn. Any problem, any doubt, anything you want to ask, just go. Yes, please. Yes, please. Anyone, any kind of doubt or problem? Okay then. So I guess no. This question will be HW for you, okay? Part of GOC although, but just try to answer the question. You have to tell me in this given compound. So don't worry, the question is from the main only, okay? It's not advanced question. Mm, okay, let me just give the number. One carbon, two carbon, sorry, three, three position, fourth position, fifth position, sixth position, seventh position, eighth position, and ninth position. Okay, so the question is what? Which nitrogen doesn't contribute to basicity? It means out of all the possible nitrogen, which nitrogen lone pair is not available for the bonding, or lone pair is not behaving like a that that they are available for a kind of donation. So basicity simply. Basicity for the compound. Options are option number one, that is the 9 3 position, sorry, N9 position. Option number B, N3 position. Option number C, N1 position. Option number D, that is N7 position. This question will be a HW for you. GUC question normally. Try to answer this question. If you're not getting, we will discuss in the next class. Okay, then that's it. take screenshot or something. Thank you so much for your time. Thank you so much for joining the class. And okay, have a nice day, everyone. Thank you so much. Okay, thank you.